Now I will start our group presentation. Our group topic is a biomass transfer. Okay, the background of study. Biomass transfer is a process of energy transfer between the biomass. It is a cycle between the living and the tree. This model describe the energy transfer between the two biomass. Okay, now for the objective of the study, we want to find out the biomass of each phase of the tree at a certain time in the future. We also want to figure out the difference between of the biomass living tree, decay tree, and humus. Then we want to determine the general solution of the biomass transfer of the living tree using a metric method of consistent linear equation that consists of the first order ODE.
Okay, so now we'll show you the process behind this mathematical modeling. First of all, the process of carbon cycle started when the living tree dies and decay over time and produce carbon into soil that's so-called as humus. The carbon transferred from living trees to humus actually represent the biomass that had been transferred. This process brings us to a mathematical model consisting three parts, and these parts are affecting each other, so we have to use system linear equation. Okay, now let's see how the mathematical model created in the slide. We let y1 is biomass decay into humus, y2 is biomass of the tree, y3 is biomass of living tree, and t is time indicate. So we will get the mathematical model for this process like this. Also, when time is equal to 0, we made an assumption for initial condition where there is no biomass decay into humus and there is no biomass of that tree, but biomass of a living tree is equal to 1 when time is equal to 0.
We move to the manual solution. First thing, we need to express the system as a metric equation. So we will have y1 prime, y2 prime, y3 prime equal to 1, 3, 0, 0, negative 3, 5, 0, 0, negative 5, y1, y2, y3, which is A is a coefficient metric. The next step is to find eigenvalues. In order to find eigenvalues, we will use equation determinant of A minus Ri equal to 0. After that, we will get our eigenvalues R equal to 1, negative 3, and minus 5. The next step is eigenvectors. In order to find eigenvectors, we will use equation A minus Ri multiplied by vector u equal to 0, which is vector u is our eigenvector. First thing, we need to identify linearly independent equation. We know that u2 and u3 equal to 0. If we let u1 as an arbitrary number s and choose s equal to 1, our r equal to 1 is corresponding eigenvalue is 1, 0, 0. Same step for the r equal to minus 3, and we get the corresponding eigenvector is negative 3, 4, 0. Also same for the eigenvalue r equal to negative 5. So the corresponding eigenvector is 5, negative 10, 4. The next step is we substitute the eigenvalues and the corresponding eigenvector into the general solution, and we will have as follows. The next step is we want to find the constant using the general solution equal fundamental metric multiplied by the constant. Next, we need to find the inverse of the fundamental metric and multiply it by the initial value to get the constant. The last step is we substitute the constant into the general solution to get our exact solution. So, this is our exact solution. For the computer-aided solution, we use a mapper software, and this is our coding. We let y1 equal to x, y2 equal to y, y3 equal to z. Then we get our computer-aided solution same with our manual solution.
From this graph, we can see that the initial of y1 and y2 is 0 because time is 0, because there is no transfer of biomass at the beginning. As the time increase, the biomass transfer start to increase and then decrease as time goes to 1. Therefore, we can say that the amount of biomass transfer of that tree decay into humus is the highest in this cycle of biological event. Next, for the conclusion, after we have done with this project, we have figured out how to solve the ordinary differential equation. This project also helped us to acknowledge the biomass of each phase of the certain time in the future. That's all from us. Thank you.